Alrighty, so with this lecture, we want to talk something about, less about the theory of circuits and more about the actual practice of working with real elements of circuits, resistors, inductors, capacitors, things like this, and some of the things you need to know about how to differentiate between the different types and all of that. Specifically for this particular lecture, we're talking about what's called the color code for, in this case, resistors, but this also applies to the other elements, like I said, capacitors and inductors and things like this. What I have here, the top left, is kind of a sample picture of typical resistors you'll see. Maybe you go on Amazon or you go to Radio Shack or wherever to buy some resistors. This is basically what they look like. You've got some metal wires hanging out the edges, and then in the center you have this kind of cream-colored thing with a bunch of colored bands on them. And those colored bands are very specific. They're telling you what level of ohms, how much resistance these resistors have. And this is important because, of course, when you go buy a new package of resistors, let's say you buy a 20K ohm resistors or 1,000 ohm resistors or whatever, that's perfectly fine. But eventually, if you're actually working with electronics, you're going to have loads and loads of different resistors, and they're going to get out of the box, they're going to be all jumbled together. And so how in the world do you know when you pick up one of your resistors how much resistance that particular resistor has? What you don't want to do is just write the number on it, because number one, it would be very, very, very small fine print, so it'll be hard to read. They can be scratched off very easily, and so instead they have this universal color code that they use to help you differentiate between the different levels of resistance. Excuse me. Now, what you're going to find with typical resistors, modern day resistors specifically, is you're either going to have 4-band or 5-band, generally speaking, resistors, which just means when you have the resistor, it's going to have 4 stripes of color or 5 stripes of color on them. So the ones I have here have 4. It's got, for instance, a red, black, orange, and gold. The 5-band would be very similar, except it would have 5 stripes of color instead of just 4. These colors are associated with this particular table that is in the bottom left corner of the screen. And basically what it says is, black, it says the digit value is 0, multiplier, blah, blah, blah. Don't worry yet about the table. It'll be very, very clear pretty soon, because this is a very easy color code, not only to remember, but also to reference back to. So first thing to know, we're going to talk about the 4-band resistors first. So the example of the picture I have at the top left specifically. We have a red, a black, an orange, and then a gold stripe at the end. And notice the gold stripe seems to be separated from the other 3 colors a little bit more. So the red, black, and orange seem to be equally spaced out, and then there's a slightly bigger space, and then the gold. And that's important, as we'll see, because one of the first things you're going to have to be able to do is know which way do I read these colors. Do I read from left to right or right to left? Because when you pick up a resistor, you don't know which end is the left end and which end is the right end. Well, it turns out the color stripe that's separated from the other ones the most, you put on the right side. And then the other colors go on the left side. So the way this is pictured, the red is on the left and the gold is on the right. And that's how it would be, because the gold is separated from the others specifically. Once you have it oriented correctly, you're going to read the colors left to right. And for the 4-band, the first 2 stripes are the digits of your number. So let's say this is going to be, let's say 120 ohms, right? So if it's a 120 ohm resistor, then that would be the first two digits, 1 and then 2, and then all the other digits after that, in this case there's just a 0, are going to be held by the third stripe. Okay? And so this is what I mean. Let's look at this specific resistor in our example picture. We have red, black, and orange, right? So red is the first stripe, then we have black, then we have orange. And let's forget about the gold for now. These are the three we care about the most. So red, we look at our table of values. Under digit value, it says red is the number 2. So, okay, the first number of our resistance is a 2. The second stripe is a black stripe, so on our table it says digit value for black is 0, so the second digit of our number is 0. And then, if this is a 4-band resistor, or 4-stripe resistor, the third color does not refer to an actual digit, like 4 or 5 or 8 or whatever, but rather it's called the multiplier. And so for the third digit of orange, we look at orange, it says the digit is 3, or the multiplier, the number of zeros, is 10 to the third. So that means we could either think of it as 10 times 10 to the third power, or we could think of it as 0, 0, 0, 3 zeros, because the orange color has a value of 3. So once we have this, we have a red, black, orange resistor. That means our resistance is going to be the first digit is 2, the second digit is 0, and then the rest of the digits are 3 zeros, because orange is the multiplier of 3. So 0, 0, 0. That is, in ohms, the resistance of these resistors, 20,000, or when you go buy them, they'd probably just be called 20K ohm resistor for 20 kilo ohms, of course. And that's what it is. If you have a 4-band resistor, you're going to look at the first 3 colors most of all. The first 2 are the actual first 2 digits of your number. The third stripe tells you how many zeros come after those 2 digits. In this case, it's orange, which is 3, so you have 3 zeros. So the resistance is 2, 0, and then 0, 0, 0, or 20,000 ohms. Now, there's still that 4th stripe over there, the gold. And if we look, when we do the 4th stripe, or when we do a 5-band resistor, the 5th stripe, whichever one is the last stripe, that's not part of the number. That's not part of the resistance. It's not part of the multiplier. This is what's called the tolerance. And what this refers to is when you're actually creating real devices and real elements that go into circuits, you're not going to create them perfectly. These aren't theoretical things like we do in the classroom with perfect numbers. They're going to be within a certain range of the number we've got from the other colors. So this resistor is supposed to be a 20K ohm resistor, a 20,000 ohm resistor. However, the tolerance, it says it's gold, and if you look under gold, it says here the tolerance is plus or minus 5%. So that means the actual value of resistance for this resistor is 20,000 ohms plus or minus 5%. Okay? So 5%, well, 10% would be 2,000, so 5% is 1,000. So the actual resistance of this resistor can be anywhere between 19,000 and 21,000. It's, on average, it's going to be about 20,000, but plus or minus 5%. And of course, the better tolerance you have, the more accurate this reading is going to be, the better the element is, and thus the more expensive it's going to be. If you need very, very high precision equipment, then you're going to pay more, and you're going to have tolerances of about 1 or 2 or 0.1% or things like this. Typically, the regular kind of resistors you're going to buy in a normal kind of circuit lab will have gold stripes or silver stripes, because you don't have to be that perfectly accurate. But that's how you read off this color chart. Very, very easy. Of course, young people have it a little easier than us old people, being able to see the colors on these resistors, because resistors are fairly small. In fact, this picture is a little bit zoomed in. An actual resistor is smaller than that. So it's not always very easy to see which exact colors these are. Like, is that an orange, or is that a yellow, or is that a brown? But eventually you kind of get used to it. But if you can see the colors, then you just use this little chart, and that'll be able to tell you what the resistance of the particular resistor is. Now, of course, you don't want to have to carry this chart around with you everywhere you go. So how can you memorize it fairly easily? Because there's a lot of crap here. First of all, we're not going to worry about the temperature coefficient. We're not going to be this precise in our lab or anything like that. When you start doing kind of higher level circuits, you may need to worry about such things. But for us, we only care about the digits, the multiplier, and then the tolerance at the end. So how can you remember it? It's very easy. If you could remember the colors of the spectrum or the colors of the rainbow, then you could remember this very easily. First of all, you have black, then brown, which aren't standard colors in your rainbow. So you start black, then brown, and then the rest is just your Roy G. Biv: red, orange, yellow, green, blue, violet. And then you have gray and then white. Gold and silver, of course, come after, but they're only for the tolerance. They're not in terms of the actual resistance itself. So if you can remember your Roy G. Biv, the colors of the spectrum, and just remember to put black, then brown before it, well, then it's very easy. Black is 0, brown is 1, red is 2, orange is 3, and so on. Okay, of course, all you have to do is just pull up your phone, Google resistor color chart, and bam, there it is. So it's very easy to reference. But if you ever forget, just remember it's in your standard color spectrum order. All right, so that's the 4-band. What about the 5-band resistor? Thankfully, it's very, very similar, almost identical, except because we have 5 stripes instead of 4, there's going to be 1 extra digit in our number. So let's see an example of that. Let's say we do a 5-band resistor, and we'll have the 5-band resistor be the colors, let's say we'll have it red, brown, yellow, then we'll have red again, and then silver. I don't have a picture of this, but let's just say these are the colors. These are the 5 stripes that are on this example resistor. Well, just as with the 4-band resistor, the last stripe, the tolerance one, is always slightly separated from the other 4. So in this case, we're going to say the silver is at the right edge, the other 4 colors are on the left edge. Now, just as with the 4-band resistor, the 5-band resistor, the first set of colors are going to tell you about actual digits in the number, and then the last color on that section tells you the multiplier. But unlike with the 4-band resistor, where you have 2 colors and then the multiplier, now we have 3 colors and then the multiplier. But you do the same exact thing. So in this case, red, that's the digit 2. Brown, that's the digit 1. Yellow, that's the digit 4. And in red, we have a 2 again. Silver is plus or minus 10%. So if we're going to write out the resistance of this particular resistor, it's going to be the first 3, 2, 1, 4. Then the multiplier is 2 zeros, 0, 0, plus or minus 10%. So this is 21,400 ohms, plus or minus 10%. Okay, so very, very similar. 4-band versus 5-band. Obviously, 5-band resistors, because they're usually the more precise resistors, because if they weren't so precise, then why do you need this 3rd digit? Because the plus or minus 10% basically knocks out your precision there. So a 4-band resistor, is usually cheaper because you don't have to be so precise, so you only know the first 2 digits of the number because the rest is within tolerance. 5-band resistors, because you can be more precise with the value, they're machined more precisely, then you may want to know more digits of the number. It doesn't mean that the actual resistance is bigger or smaller or anything like that. In fact, you could have a 5-band resistor that's 20,000 ohms or a 4-band resistor that's 20,000 ohms. It's just that the 5-band resistor likely will have a tolerance that's maybe plus or minus 1%, whereas a 4-band resistor is probably plus or minus 5 or 10%, because you don't need to be so precise. But that's all there is to it. Given more modern day resistors like the ones pictured here, if you just, pick up a plastic box that has a whole bunch of components in it and you're looking at a resistor, you say, oh man, I need to find a 10,000 ohm resistor. How do you know what it looks like? Well, you say, okay, I need 10,000, right? So I want a 10,000 ohm resistor. And let's say we're doing a 4-band, all I have is a box of 4-band resistors here. So what colors should be on this resistor for it to be a 10,000 ohm resistor? Well, if it's a 4-band, I have 2 digits I know. The first digit is a 1, second digit is a 0, and then we have the multiplier, which is how many zeros come after those digits. In this case, it's a 3. And so I better find a resistor whose first color is brown, second color is black, third color for 3 is orange, and then whatever tolerance it is we have, a gold stripe or a silver stripe or whatever it is for the fourth one. So if I want a 10,000 ohm resistor, I need a brown, black, orange. If I want a 20,000, it's going to be a red, black, orange, and so forth. So you could go back and forth. You could find a resistor, figure out what its resistance is, or say, I'm looking for a particular resistor, which colors, which color should the resistor have on it, and then I look for those colors. But anyway, that's really all I have for this particular lecture. As I said, this is usually you learn this when you're looking at resistors, but it's also true of inductors and capacitors as well. It's a universal coding system that they've developed for these electronic components. And so once you get used to it, it goes pretty quickly, especially if you remember your Roy G. Biv and things like that. Anyway, hope this is helpful. Good luck with the homework and the assignments. Let me know if you have any questions, and I'll see you next time.